All right, we are now on lesson 14. It's almost the same thing, computing actual length from a scale drawing. Our learning objective again is that given a scale drawing, we will compute the lengths in the actual picture using a scale factor.
All right, so taking a look at example 1, the distance around the entire small boat is 28.4 units. The larger figure is a scale drawing of the smaller drawing of the boat. We want to state the scale factor as a percent, then using that scale factor to find the distance around the scale drawing.
So first, always label which one's the original and which one's the scale drawing, because that ends up becoming very important later on. Now, please remember that we are going to continue using part equals to percent times whole in this case here. Now your whole this time is going to be your original, which in this case is a small boat, and then what we're going to be using for part is a scale drawing.
Now they're letting us know that the distance around this entire boat is 28.4 units.
Now the issue is that we can't count up all these boxes because sometimes they're a little bit slanted and they're curved here. So we can't really just count up all the boxes around this bigger one to tell us what the distance around it's going to be. So what we're going to do instead is use any vertical or horizontal units that we have here. So we can either compare the horizontal length from here to here in the original and from here to here in our scale drawing, or we can use the horizontal length from here to here or from here to here. When it comes to a drawing, you want to make sure that when you're looking at the units, they're whole units. So I didn't pick this length right here because if you look on top of here, this is around a half. I'd rather not use half. I would rather just use whole numbers here. So if I take a look at my horizontal distance of this boat here, this is going to be 8 units. And if I count up all the boxes right here, that's actually going to be 22 units. So you want to make sure that you have numbers for both the original and the scale drawing of the same thing. All right, so you could also have used this and you could also compare it to this. So at this point right now, I want us to find out what the scale factor is going to be. So like I told you earlier, part is going to be your scale drawing. So that means in this case here, I have 22 as my part. My percent, I don't know what that is yet, but my whole is my original, which is 8 units. To find out what the percent is going to be, divide 8 on both sides. 22 divided by 8 should be around 2.75. And to change this into a percent, you need to do 275%. So that means this is our scale factor here. Now, using this information, we need to figure out what's the distance around this larger boat. So again, we're going to be using part, percent, and whole. We know that our percent is 275% from what we found out from our first part there. They're letting us know that the small boat has an entire distance of 28.4. And from what we said earlier, our original is the small boat. So that means our whole is 28.4. That means we don't know what our part is. So what we're going to do is part equals to percent times whole. P equals to 275% times 28.4. Please remember to change this 275 into 2.75 times 28.4. So that means the distance around the boat is going to be 78.1 units. All right, so the distance around the large boat the large boat is 78.1 units.